Okay, today we're going to look at dilation and reflection. However, before we do that, I want to look at inverse. And this is just a quick little review of inverse from the first unit. So if I told you to find the inverse of f of x equals 3x minus 8, you would need to switch x and y and then solve for y. So literally switch x and y. So x equals 3y minus 8, and then add 8 to both sides, and then divide by 3. Okay, so that was the first way we learned, and that is to find the inverse. So we switch x and y, solve for y. Now, I also taught you how to do it on a calculator, so we're going to look at that in just a second. So the slope, notice the slope goes from 3 to 1/3. So that is something that will happen every time. So if the slope was 4, then the inverse slope would be 1/4. If the slope was negative 3/5, then the inverse slope would be positive 5/3. So that happens every time. The y-intercept, however, has no real relationship from the original to the inverse. So you just have to find it. So no real relationship. Okay, so that's the first method. Switch x and y, solve for y. That's the first thing that we did. The next one, so the next way to find inverse was using our calculator. And for this one, this is another method. You put it in y equals, so y equals 3x minus 8. And you put it in the calculator, and then you look at the x and the y, and you just pick 2 ordered pairs. So look at the table, pick 2 ordered pairs. Then you take those 2 ordered pairs, and you put them in L1 and L2, but switch them. So instead of 1, -5, it would be -5, 1. Instead of -2, 2, it would be, instead of 2, -2, it would be -2, 2. So you put that in your stat in your calculator, and then you get y equals, and it would be the same as the one from before. So I hope you put these notes in your notebook. We are going to look at this again tomorrow, but we have to make sure we know how to do inverse. So the key for inverse is switching x and y. That's the most important thing that we do. But you have to be able to find inverse of one function and tell me its inverse. Okay? And it's not 8x minus 3, which is what a lot of you keep telling me. So know that that is not how you find inverse. So you switch x and y, solve for y. So yesterday we looked at the parent functions, and how many are there? There are 7, and we talked about we need to know their name and their equation and their domain and range. So if you remember yesterday, in the transformed equation, we had 3 letters in the transformed equation, A, H, and K. So for example, for quadratic was y equals ax minus h squared plus k. So A, H, and K. So we're going to spend the next couple of days looking at these, and today we're going to be looking at the A, and what does the A do in an equation. So the way this works is you need to graph each one of these with 3 different colors, or however many different colors there are. So this first one for quadratic. In your calculator, I want you to type y equals 2x squared. And the way you can graph these is do second graph, and that will show you the table. So second graph, and that will show you the table. Then you find ordered pairs on the table, and then you complete the graph. And these don't need to be perfect, they just need to be kind of sketches. So there's the first one for quadratic, and so that's y equals 2x squared, and then this is y equals 1/2 x squared. And then the last one is y equals -3x squared. And that might take you a little bit longer, so we're going to pause here in just a second to look at how to do these, but give you some time to do it. So, but those should be the 3 that you graph. Then look what happens. So what happened for the red? Okay, it got more narrow. We call that a vertical stretch because it got skinny. Okay, it's called a vertical stretch. And then what happened for the blue? Okay, that got wider. We call that a vertical shrink. And then what happened for the green? It also was a vertical stretch, but it reflected over the x-axis. It went facing down. Okay, so what you're going to do for the rest of these is we're going to pause the video, and then you try it, and then we'll play the video and check your work. Pause, you try, play the video, check your work. So that's how it's going to go for the rest of these, and by the end, I hope you start to see a pattern. Okay, so pause the video and try the square root function. Okay, so now I'm going to show you the answers. Okay, so there's 2x, there's 1/2 x, and there's negative 3x. Okay, or negative 3 square root of x. So those are the three that you should have graphed. Yours should look very similar to these. And once again, you should be looking at the second graph in your calculator. Okay, so let's pause again and then look at the next function. Okay, so here's a cubic, 2x to the third, and then 1/2 x to the third. Okay, pause again. Next we have a rational function, and like I said, graph this in your calculator and it's going to help you find these patterns. Okay, so there's the 3 over x. So a is 3. Here's the 3 over x. And then the negative 0.5 over x. Notice it reflects over the x-axis. So hopefully you're taking the time in between each one of these to graph, to spend the time graphing using your calculator. So pause the video again. Okay, here's exponential. And logarithmic. Okay, and I think that this one should actually go a little bit more right here. Okay, and then the last one, so make sure you've got these down, and then the last one is absolute value. Okay, so what I want you to do right now is I want you to look at all 7 graphs, and I want you to see if you can find any patterns. Okay, what's happening when A is big? What's happening when A is little? So like when there was a 2 in front, what was happening? When there was a 1/2 in front, what was happening? And when there's a negative 3 in front, what was happening? See if you can answer those questions. And then let's see if we can find an overall pattern. So take some time, take 4 or 5 minutes, discuss that with your shoulder partner. What are the patterns that you see? What happened every time it was a 2, a 1/2, or a negative 3? Okay, hopefully you started to find these patterns. When A was greater than 1, meaning when it was like 2, it was a vertical stretch, we call that. We call it a vertical stretch. Okay, when A is in between 0 and 1, so when it was like a fraction, when it was like 1/2, we call that a vertical shrink. Okay, other words for these, or another way to think about it is for a vertical stretch, the function gets closer to the y-axis. For a vertical shrink, it gets closer to the x-axis. So go back and look. Can you see how each one of these got closer to the y-axis or closer to the x-axis as you graphed them? So look at all 7 of your functions. Do you see when A was 2, how it got closer to the y-axis, but when A was 1/2, it got closer to the x-axis? Okay, and then when A was negative, anytime A was a negative, it reflected. Okay, negative makes it reflect. Now we did -3, which also made it stretch, also made it get closer to the y-axis, but it reflected over the x-axis and it stretched because it was -3. So these are the patterns that I hope you saw. So write these down. So you're going to need to know when a was negative, when a is a fraction, and when a is greater than 1. Okay? And finally, just make sure that you realize these is all based on the transformed equation. So on your note cards from yesterday, there was the transformed equation, and there was the A, and it does dilation and reflection. Okay, the A is in charge of dilation and reflection. So go back and look at the A for all 7 parent functions and know where it is, and it makes it get smaller and bigger, and it makes it move up and down. So tomorrow, we're going to look at H and K, and I'll give you a hint. H and K move left and right and up and down. So if you have any class time left, I want you to work on your flashcards and start looking at those. And remember, we have a quiz on that on Friday. So have a great day. I hope that you have graphed a lot today and you understand that what dilation means bigger and smaller, wider and narrower, vertical shrink, vertical stretch, and reflection, meaning that reflects over the x-axis. And I'm excited to talk about shifting left and right and up and down tomorrow. See you guys later.